Good? Okay. All right, so let's get started. Can everybody hear me okay? Okay. So we're going to talk today about attacking Windows Communication Foundation, or really services that use WCF to talk to clients. So just a quick overview as to the outline of the talk. The objective is really just to talk about different tools, different ways you can either attack an application or pen test an application that uses WCF, and also ways that you can potentially abuse some of the WCF bindings to do stuff. So we're going to talk about just a little bit of overview as to background on WCF, and then we're going to go through three scenarios. One is going to be a Silverlight application that talks to a WCF service. Another one is going to be some interesting stuff around WCF duplex services, and we'll talk a little bit more about what that is. And then we're going to talk about WS security and some of the security options that WCF has that makes, from an attacker's perspective, things a little bit more difficult, but certainly not impossible. So WCF is really the core communication framework going forward for .NET applications. So the interesting thing from an attack perspective is that the only new thing that complicates life from a remote attacker's perspective is the different bindings and protocols and message formats that the web service expects. And what we're going to see here is a lot of the tools out there, or the classic web services tools, do not support a lot of this stuff. So it becomes a little bit tedious trying to figure out how to talk to the service. This is just a diagram that I pulled from one of the Microsoft sites, and really the message here is that you can see all the different legacy communication mechanisms that .NET had and Windows had, and really what they've done is they've tried to roll them all up into one framework that allows you to then basically talk to anything from any .NET service. So it's pretty cool stuff. The key here is that when you talk about a WCF service, there's really three things that you normally hear about, and a lot of times they call these the ABCs of the WCF endpoint. So there's an address, a binding, and a contract. And really what we're most interested in is the binding. The address is important too, but the address is really just the URL or the location where you can find that service. So it's pretty standard. You can see the notation there. It's just like a URL that you'd expect to plug into a browser. You've got the transport, the machine name, if there's a port number that's not running on a standard port, and then potentially a URI. And one of the ways you can always tell when you're talking to, or a good giveaway that you're talking to a WCF service is if you remember back in the legacy .NET web services have the .asmx file extension. A lot of times you hear those referred to now as ASMX services. So a WCF service is going to have a .svc file extension by default. It doesn't have to, but more often than not, that's what you see. So if you're looking at a web service and you see a .svc file extension on a web server, that's probably a WCF service that you're talking to. The binding is really the key thing that we need to think about or we need to know about before we attack the service. So the binding defines not only the protocol that's going to be used, and there's a bunch of different protocols that are supported out of the box, but also the message format, the encoding of the message that's going to be used as well. So I've got a slide here of just some of the more common transport protocols and message formatting options that WCF supports. From a remote attacker's perspective, if we're talking about something on the internet, you're probably going to deal with mainly the ones that are highlighted in yellow. And more often than not, you may not even see net.tcp up there. If you're talking about something on the internet, that's more of an intranet binding, but you could certainly see it. It will work over the internet. And then from a message perspective, there's a lot of text-based message formats like SOAP, XML, the stuff we're used to. But then there's a new binary message format as well that's optimized for services that are both written in WCF to talk to each other. And that's what tends to complicate things a little bit. And then finally, the contract. The contract is really just defines what methods, what data types you're able to pass in and out of the service. From an attacker's perspective, you're just going to have to deal with the contract that the developer published. The notable thing here is that it is an opt-in approach. So by default, there is no method that's exposed. The developer specifically has to expose everything. So the good news is Microsoft has tried to to really harden a WCF installation out of the box, you've really got to turn everything on. But as we'll see here in a few minutes, normally most of the developers will tend to go with the common settings that will allow us to do whatever it is we need to do. So I'm going to go through three scenarios, and there's going to be a lot of demos here, so hopefully the demo gods are not going to frown on me today and things work. We're first going to look at a Silverlight 3 application that talks to a WCF service. We're then going to talk about a duplex binding in WCF that you can actually use to remotely turn any WCF service, or not any WCF service, but one that's using this specific binding into a port scanner of sorts. And then we'll go through and look at some of the security settings, the WS security options that can be used as well. So the first example we're going to do here is a Silverlight client service. So starting with Silverlight 3, there's pretty good support for WCF and Silverlight. So by default, if you write a Silverlight application that talks to a WCF service, it's going to be using the .NET binary SOAP protocol for exchanging messages back and forth. And the way you can tell this, if you look at it, if you sniff it, or if you look at it in a proxy like burp or any of the attack proxy tools, you'll see that the content type is actually set to SOAP MS bin 1. And that's basically a proprietary protocol that Microsoft has developed. It's a binary XML message format, and they've published the spec on it up there. But it is intended for Windows or Microsoft components to talk to each other. So there's what I found is, this all sort of originated several months ago when I was looking at a Silverlight application that was using this format, this message format. And what I found is I needed to manipulate the data going into the service, as you typically do when you want to test a web service. And the problem was that I wasn't able to really even see or certainly not manipulate the messages. And most of the tools out there didn't have support. So I looked at Fiddler, which is the one that had the closest thing to support, which is a sort of a local proxy tool that you can use. A lot of people are familiar with this. And a guy named Richard Berg actually wrote a binary XML inspector for Fiddler. And this is what it looks like if you were to use it. It actually will show you, and I'll show you in a minute what the raw binary data looks like. He actually converts it to readable XML that you can then view in Fiddler. Now, the key problem here, though, is that this is a read-only interface. So I'm not sure if it's a limitation of the Fiddler API or just a limitation of the inspector that he wrote. I actually went back and forth with some emails on him, and he said it's a limitation in the API that allows him to just to have read-only access to this data. So it's great for looking at the data that's going back and forth, but you can't edit it, and that's sort of a key requirement from an attack perspective. So let's take a quick look at what this actually looks like in the browser and through proxy. I've got a little test web service. You probably can't see the URL up there, but it's just running on a VM on my machine here. And this is just a sample MSDN sample calculator that they publish. There's a bunch of different calculator examples they have for showing how to do stuff with WCF. So you just put in 3 plus 3 here. You hit the equal sign. The web service then calculates it and returns 6. So if I go ahead and I'm going to use a local proxy called burp, which a lot of you guys are familiar with, I'm sure. And I'm going to go ahead and turn burp on here and intercept this request and see what it actually looks like. So we'll do 4 plus 2. And if I go down to burp, what you'll see here is this is what you actually get in the burp interface. It's a bunch of garbled binary data. You really can't even see the numbers that I typed in there. And if you try to edit this, even if you look at it in hex, it's not actually going to show you the data that you need to see. And the reason for that is, as I mentioned, this is a compact binary XML format that really just puts a bunch of different binary markers into the message instead of the actual XML attributes. So from a test perspective, we need to be able to decode this. So I was looking around. I mentioned that I saw in Fiddler that there was this is an open source component in Fiddler. So I started looking at the code and thought that it would probably port quite well over to burp, which I've written a plugin for before. It has a pretty easy to use plugin interface. And I know that with burp, we'd be able to transform that data as opposed to the Fiddler interface, which would be read-only. So There's a plugin that was written a few months ago. I released it back in November, and it's basically a plugin for Burp that decodes. It uses the same logic that Richard Berg used, basically just ported his logic over and converted it to Burp. And the way the Burp interface works is there's two methods that it uses. One's called the process proxy message, and one's called process HTTP message. And simply, one of them will hook into the message before you intercept it. The other one's going to hook into the message after you intercept it. So what it's going to allow us to do here is, I've got it running, and I'll show you that same exact message going through the Burp proxy interface. I've just got a second instance of Burp running on port 8081. And what's going to happen here is, let me just make sure the intercept is turned on. And if I go ahead and submit another message, say 23 plus 3, and we go down to this Burp interface, you can see here that now I'm actually looking at readable XML. So this becomes really easy for me to then go ahead and manipulate. So I'll change this to 53 plus 3 and forward it on. Now the interesting thing is that you'll notice here when the response comes back, it's still binary. And I'll talk about that in a second. But at a minimum, for editing the request, this works pretty well. So that's a free plugin. You can download it off the GDS security website. Now, the one thing you'll notice there that I pointed out is that the response data is still encoded. And the reason for that is that the two methods in the Burp interface that we're hooking into, process proxy message and process HTTP message, both actually get hit on the response side before you can edit the data. So there is no method to hook into, and this is something that I contacted Portswigger about, who's the guy that wrote Burp, just to confirm that there was nothing I was missing here. And there really is no method you can hook into to transform the response data after you intercept it. So there is a workaround for this, which is a little clunky. It's not very elegant, but it works. And that is, you can just chain two of the proxies together, and then you set the first one to decode and edit the requests, and then the second one to decode and edit the responses. So you have one instance doing your requests, one instance doing the responses. And then the way that each of those ends up talking to each other is they set the plugin actually sets a custom header that notifies the next proxy in the chain that the message either needs to be encoded or decoded. So if you do need to edit response data, it's not a very common scenario. This is really just if you want to try and trick the Silverlight client into doing something and thinking that the web service gave it something it shouldn't have. You can certainly use this workaround, and it'll get you there. So at this point, even if we're looking at a Silverlight application, we still need to get metadata, or we're still going to want to get metadata about the web service. And the reason for that is that if we're only looking at the Silverlight client and we're only exercising the Silverlight client in the browser, we may be limited as to the calls that the Silverlight client is making. There could be a bunch of other good stuff back there that we want to get to. So just like in the legacy ASMX web services, there is a way to pull a metadata, the WSDL, the WSDL, through a GET request. And that's the same way you used to do it. It's basically append the question mark WSDL to the end of the address, and if that feature's turned on, it'll return the WSDL. The drawback here is that that is not turned on by default in WCF. As a matter of fact, none of this stuff is turned on by default. There is no metadata that comes back unless the developer turns it on. So that's another example of this sort of opt-in approach that Microsoft's taken, where historically the WSDL was published all the time unless you turned it off. That's not the case anymore. There's also a second mechanism of getting metadata from the web service, and that's basically using what's called the MEX binding. And MEX is basically short for metadata exchange. It's actually an open standard. There's a W3C draft on it, and it's a specific message standard for obtaining metadata from a web service. And the way a MEX request works, this is just an example. If the helper page, if you remember back in the legacy services, they always had this helper page that would get displayed. It used to show you the different post requests that you could make to talk to the web service. It doesn't do that anymore. It just basically shows you how to generate an interface to the web service if you needed to. The other thing that you'll notice there, and we'll talk a little bit more about this later, is you'll see that there's a cryptic host name there, even though that doesn't map up to the host name that's in the URL. And the reason for that is by default, the web service is going to return its host name within the metadata. There's an option you can turn on to change that and make it a fully qualified domain name. But if you're trying to obtain this metadata and you're having problems resolving a host name, it's probably because the web service is returning its internal host name and not the fully qualified domain name. So the good news is that while all of this stuff is turned off by default, if you use Visual Studio to generate your web service, which 99% of people out there do, it's going to generate an automatic template for you when you go to create a new web service. And by default, in that template, it's turned on the metadata, the WSDL through the query string, as well as defines an endpoint for MEX with a address of MEX, as you can see up here. So the good news is that even though it's off by default, I'd say a good 80% of the time you're going to end up having access to the metadata anyways. And the way you would obtain this, if you want to issue a MEX request to the web service, is it's a post to the address of the service along with whatever address was defined for the MEX endpoint. So again, if they're using the default Visual Studio settings, it's just going to be /MEX. And then you have a very simple body here that basically just includes the address that you're actually issuing the MEX request to, and it'll then return the data. So I'll show you an example of what that looks like here. In our Silverlight service, we've actually got the metadata turned off for, just pull it up here. Metadata is actually turned off for this web service. So if I look at the history, I can see I'm actually going to Silverlight Calculator service.svc. And I'm just going to go ahead and turn off burp for now since we don't need it. You'll see that if I issue a GET request, it actually returns a 404. So it's actually kind of tricky in the sense that you might actually be fooled into thinking that the web service isn't even there. The thing is that it is there, but if metadata is turned off and specifically the GET method is turned off, which is what we've done here, it's just going to return a 404. So the way to get metadata out of this endpoint is going to be to issue a MEX request. And I'll show you real quick what that looks like. I've got one in burp repeater all set up here. So we're just going to issue a request, as I said before, to the address along with /MEX. And the body is identical to that message that we saw on the slide. And what you'll see there is it basically returns all the WSDL information. It just returns it in a SOAP envelope instead. So it's basically the same information you used to get. It's just a different way of getting it. Now, this still might not be enabled if they've gone through a security review and somebody pointed out, hey, you shouldn't be publishing your metadata. You may not be able to do this. One thing to keep in mind is that while it is turned on by default in the Visual Studio template, with WCF, you actually have to specify whether you want metadata to be published over HTTP or HTTPS. So if you're accessing a web service over HTTPS, even if they've got the metadata turned on, which is by default in Visual Studio, it's the top one there, which is only over HTTP, it will not serve MEX requests or WSDL requests over HTTPS. So that's another thing that may have you sort of banging your head against the wall is, why can't I get this metadata? It is specific to HTTP or HTTPS, so certainly try both if you have access to both. The other thing now is that there's, as we've seen here with burp, and with Fiddler, there's not many tools out there that support, a lot of the standard web service testing tools out there don't support the different types of protocol bindings that WCF uses. So there's a couple that you can use there that are free and easy to get to. The first one is the default WCF test client that comes with Visual Studio. If you don't have Visual Studio installed, there's a guy who posted, he basically just extracted the relevant DLLs and files needed to run this client, and he published in a zip, so you can download it for free and pull it that way. The other one that I like that has a free version is called WCF Storm, and these are both GUIs that make it sort of nice and easy to, I'll show you an example of the Visual Studio one. It basically, you just load up the web service, you point it towards the metadata endpoint, and it'll then generate a GUI that'll allow you to plug in values and show you the response that comes back. And the nice thing about these two tools, the reason I'm using them, is that no matter what the protocol binding is that they're using, for the most part, these will support, these are written in .NET, so that it's basically just like another .NET application talking to that service. And we'll talk a little bit more about those utilities in a second. The other option you have is, okay, let's say we have no metadata that's being published at all. They've locked the thing down. Well, if this is a Silverlight application, the nice thing we can do is if it's consuming a WCF service, chances are all they did was generate a stub to the web service using the Visual Studio Service utility, and that stub is going to include all the relevant metadata and methods that we need to talk to the web service. And that stub is actually going to be in the Silverlight ZAP file as well. So the other option we've got is if we go back to our Silverlight page, we can actually just directly get the URL to the ZAP file, doing something like a view source, and then we can issue a direct request to that ZAP file, pull it down, and then we can decompile it very easily, just like you can decompile any other .NET application. So if we actually make a direct request to that, we should be prompted to save it. So we can just download that directly to, I'll do it to my desktop here. And then once you do that, you can actually just open it with WinZip or 7-zip. If you open that up, you'll see the different files that are in the ZAP file. The XAP or the ZAP file is basically just a zip file that includes a configuration, whatever configuration information Silverlight needs, as well as the .NET compiled DLLs that the application uses. So if I just drag this DLL out, and then I can actually open it up with .NET Reflector. What you'll see here is that within that Silverlight, within that DLL, you're going to have a service reference that's going to basically have all of the metadata that you need to talk to that web service. The way I like to do this is there's a plugin for Reflector called the File Generator that a lot of you may use. And what it does is it makes it really nice. You can just right-click on the file and hit Export, which should be an option here. My machine's kind of hung for some reason. This isn't good. Well, we'll give it a second. There we go. So when you right-click, if you do an export, it'll go ahead and, I think you have to do it on here. It'll ask you where you want to export it to, and the nice thing about the file generator is it generates a Visual Studio project with all the decompiled CS files. So I've already done that, and I got it open here so you can see what it looks like. This is really a much better interface to be looking at this stuff with instead of the Reflector interface. And you'll always see in your service reference that you're going to have the service class that has all of the endpoints defined here. So the interesting thing is that while our Silverlight application is only using the calculate method, you can see here I added another one just called test echo that's actually not being used by the client. So the nice thing is, irrespective of whether or not the Silverlight client is using these methods, the interface to call them is going to be defined within the ZAP file anyways. So this can be a pretty effective way of pulling that metadata as well. And then the last way that you can potentially get metadata, which is a new one, is known as WS Discovery. This is actually still in beta. It's coming out in the version 4 of the .NET framework. WCF's going to support it. And essentially what this is this is an open protocol that's been around for a while that allows web services to dynamically discover each other on the network. So if an address changes or something changes in the middle of the day regarding one of these services, the web service can announce the changes and broadcast it to the network. It works over UDP. It's multicast. So it does run on 3702. And the way it's intended to work is these web services just broadcast messages to all the different web services on the network. And there's 4 different types of messages. There's a hello, a bye, which are pretty self-explanatory. And then the ones from an attack perspective that would be useful are the probe and resolve methods. So you can actually start probing and searching for different services. I haven't seen this at all in use in practicality, simply because it's probably I don't think anyone's going to really use it widespread until it's out of beta, but certainly some cool stuff, and I think down the road this is something that we're going to start to see a lot of once it comes out of beta. So that's sort of the Silverlight angle. The other thing I want to talk about is some of the other interesting bindings that WCF has. And specifically, there's a subgroup of bindings that they refer to as duplex bindings. And duplex bindings, as sort of the name implies, allows two-way communication between the client and the server. So not only can the service be requesting information from the service, but the service can actually push data down to the client. So it's really nice for applications where you're just sort of subscribing to a notification and you're waiting. There is an option that allows for the clients to poll at regular intervals, but that's not going to be real time. The true duplex bindings are pretty real time, so the service can then push data down to the client. Now, the interesting thing about the duplex bindings is there's one specifically that operates over HTTP. It's called the WS Dual HTTP binding. And this one really caught my eye when I was looking at it from a security perspective, because HTTP is sort of a one-way protocol. There's a request and a response. So the way they've implemented the dual binding that runs over HTTP is that the client actually opens up a web server port on the machine and listens for incoming messages from the service. So that, of course, is a little bit alarming when you think about it. It's like, wait a minute, I'm opening up a port that's running a web server. It's a lightweight web server. It uses the same API that IIS uses. It's the Microsoft HTTP API. And really, it's specifically there to receive these incoming callback messages from the service once the communication channel's been open. And the way it works is there's a create sequence request-response process that occurs at the very beginning of the conversation to set things up. And this is really where the interesting stuff happens. The first thing you do is as a client, you issue a request to the service, and the action is going to say create sequence. And you're going to include a reply to URL, which is going to be your host name and the port that you are opening up to receive the callbacks on. So in this example, it's client. I'm using port 8000. The service is then going to open up a new conversation to the client and send a create sequence response to that port. And again, this isn't a response to my request. This is a separate request that's being initiated by the service. It's then going to respond back to the client with a 202 accepted on in response to the create sequence request. And then the client is going to send a 202 back to the service. So the important thing to note here is that there's two completely separate conversations going on. One is between the client and the server going over port 80. The other one is between the server and the client going over whatever port the client has opened up for this purpose. So that's how it's supposed to work. If we look at you can sort of look at a scenario now where we've got two machines. We've got a client, and then we've also got a target. In this scenario, let's say I send a message to the web service. I'm client 1, and I say, let's do a create sequence, but reply to target on port 8000. What's going to happen is the web service is going to then initiate a response to whatever machine I tell it, specifically in this case, the target machine on that port, and then it's going to send me back an accepted response to my request. Now, the interesting thing here is that this target did not ask for this request. So that's obviously going to time out. But the nice thing about it, again, from an attack perspective, is we now have a capability to force the servers to start issuing requests to other machines. So we're going to see how this can become a little bit, this is a little susceptible to abuse here in just a second. So now let's open up a scenario where we've got three machines. We've got one client and two targets. So if I send a request to the service that says open up a connection to target on port 8000, it's going to turn around and do the exact same thing it did just now. It's going to make this request to the target on port 8000, and it's going to send me back an accepted message. Now let's say I issue a second request to the service, and I say now connect to target 2 on port 8000. Well, what's going to happen here is the request to target 2 is not going to go through immediately. And the reason for that is that the service is still waiting to get the acknowledgement back from target 1, which hasn't happened. So, and I haven't looked at the .NET code as to how this actually works, but it appears as though the framework is just queuing these requests, and it's only sending one at a time, because what ends up happening is only until the connection to target 1 times out do I end up getting a 202 response on my second request, which is when that second request to target 2 comes out. So it's a little confusing, but we'll see how this can be used here in a second to do some fun stuff. So specifically, you can actually use this to do port scanning of sorts. Because if we look at the create sequence request, what's happening there is this is the address and port that I'm telling it that I'm expecting my callback on. So if I change that to any other machine and any other port, the web server is going to actually start making connections to that. And the timing of how it responds to those subsequent requests is going to determine whether or not that connection worked. So I'll show you a real example of how this works. I've got a web service running on the VM here on port 88 that's using the dual binding. So this is my create sequence request. You can see here I'm going to tell it just to go to localhost on port 80. So it's just going to go to itself on port 80, which doesn't necessarily make sense, but we do know at least that that port is there and it's open. So I can make these requests all day long, and you'll see here that I'm getting an accepted that comes back within a second or two. So now let's change this to some other random IP, like 1.2.3.4, and hit submit. You'll see I immediately get a response back, but if I issue a second follow-up request, I'm not getting my response back. And the reason for that is that it's waiting for that initial request to time out. And once it does time out, it'll then return a response to me. So I thought this would be interesting to sort of play around with. And in sort of doing some research and kind of playing around with it, I developed sort of a crude console application that I called WS Dual Scanner. And really what this does is it converts any web service that's using this binding into a remote port scanner. And the cool thing is that because depending on where that web server is, you can actually start scanning other machines in the same DMZ or on the intranet, depending on where this thing is, through this callback request mechanism. And it's a little slow, but it is effective. And the way it works is it basically issues the first request, doesn't really care what the response is to that because it's going to always come back immediately. But then on the second request, it's then going to wait and measure the response time to figure out whether the first connection timed out or not. And then it's just going to keep on doing that and probing different ports. So to do a proof of concept, what I did was I actually created a web service. It's a standard calculator web service from MSDN, and actually deployed it to a VM in the Azure cloud. So the way Azure works, which is Microsoft's cloud platform, is you can publish, you buy a subscription, you publish web services in VMs that get deployed into the cloud. And the way their cloud works is it's actually sitting on a 10-dot network with all the other VMs. And it's behind a firewall that they then translate your host name. So every time you deploy an app, you create a host name. So if it's myapp.cloudapp.net, and cloudapp.net is the standard domain that Azure uses, that's actually going to be translated inbound to one of the VMs on the 10-dot. So what we're going to do here is just the proof of concept. I'm going to pull up the web service that I've got here, and we're just going to quickly try and scan the other VMs. I actually have an internet connection here from my Verizon card. So you'll see this is the actual URL to the Azure web service, which is sitting on the Microsoft cloud right now. You'll also notice here, which is kind of what we talked about before, I'm getting the internal host name of that VM. So if I tried to pull the metadata and tried to resolve it with the WSDL that way, all of my utilities are going to break. So the reason I'm pointing that out is just keep in mind you'll need to use something like burp. If you're actually trying to pull the WSDL and do testing, you're going to need to use a tool that does a search and replace on these host names. Otherwise, you're not going to be able to talk to it. But for now, the way this little port scanning thing works is it's pretty crude. It basically just takes in, let me just pull it up here. So it basically just has two options. You can either scan a range of ports on a specific machine, or you can scan a specific port across a range of IPs. And if you look back at that helper page here from the Azure web service, you can see it's actually running internally on port 20,000, which you'll notice here. And that, again, for some reason, they run all the internal VMs run their web services on port 20,000. That just gets mapped to port 80 when it does the inbound NAT. So what we're going to do here is we're going to go ahead and launch this against, I'm going to point it towards my web service, and I'm going to tell it to scan, and it's kind of slow, so I'm just going to do about 10 IPs right now. We're going to tell it to actually scan 10.115.213, I know that's the network that my VM sits on. We're going to have it scan .30 to .40 on port 20,000 and see what other machines have that port open. So the way it works is it just actually measures that response time for that queued response that I was talking about before. So you can see here it's already measured the response time as around 7 seconds for the boxes that are not listening on that port. Either it's closed or it's probably just timing out. And then the ones that do have that port open, it's getting a response pretty quickly, somewhere around 3 milliseconds. So just to verify that this is actually working, what I did was I actually just uploaded a ASPX shell to that VM as well, and I uploaded fscan, which is a command line port scanner that you can use, and I'm just going to run fscan against the exact same range of machines to verify that that scan is actually working. So I'm just going to go ahead and run fscan against .30 to .40. And this will go really quick, hopefully. And what's going to happen is it comes back with 31, 34, 36, and 38 are listening. So if I go back to the results of the scan here, it's pretty much those exact same machines that the little hack utility here determined were open. So that's just sort of an example of how this callback mechanism can really be abused to start issuing arbitrary requests to other machines, again, potentially on an internal network that you wouldn't normally be able to get to. And if anybody's interested, I can post the code to that utility. It's not very useful. It's just more of a funny thing. So the next walkthrough is going to be a secure WCF binding. And this was one that I had a demo lined up for, but I don't think we'll actually do a demo, but it certainly makes sense to go through it. The WCF framework allows developers to implement the WS security standards pretty easily. So WS security allows for things like message level encryption and all sorts of stuff that make it very cumbersome to start talking to the web service manually, because you really can't even craft, you can't really craft those requests manually because you have to negotiate certificates and all that stuff. So there's a handful of options that are going to be very important to figuring out how you're going to talk to a web service that uses one of the security settings. The most important thing is going to be it's driven off the mode, the security mode that it's operating in. So if you actually pull the metadata for a client, we'll actually look at this is the metadata for a secure web service I've got on port 89. This is the test utility that comes with Visual Studio. It'll actually go through using that metadata and create the configuration file that you would need on the client side to talk to this web service. So if I look at the security mode here, I can see that it's actually running in message security mode. That's always, the security mode's usually going to be either none, which is great, then you don't have to worry about this, message, which means it's going to do message level encryption, transport, which means it's going to require SSL or some other transport encryption, or message and transport, which means both. So the reason this is important here is that if you see message encryption, normally you're going to need, the requirement is you're typically going to need at least one certificate to use message level encryption. Now that doesn't mean that you're going to need to have a client-side certificate. It just means that you're going to need to use a certificate, potentially one that's going to be provided to you by the web service. So there is a scenario that you can set up where you can have anonymous message encryption. And the reason for that is the encryption is going to serve as just to protect the data. We're not interested in authenticating the user with using message level encryption. We just want to make sure that we don't need, in this case, we might not be using SSL, so we can exchange sensitive data and know that there's going to be a secure key exchange that occurs, and a middleman is not going to be able to read that data. So if you actually try to communicate with this service initially, you're going to get an error that gets thrown by the framework. And the reason for that is that you'll see down here, there's a certificate, an encoded base64 encoded certificate value. It's probably hard to see, and I can't increase the font size on this tool, unfortunately. But that's actually the server certificate. And what you can do here is that if you just take that certificate and plop it into, it's base64, so just plop it into a file and then import that locally. You'll then have the server certificate that within your certificate store that you can use to start talking to the service. The reason it's going to throw an exception is that this certificate, if this was a valid SSL certificate issued by a trusted CA, you can actually do this out of, you don't necessarily have to import the certificate. The problem is if you try to do this now, and I can even try to invoke one of these methods and see what happens, you're normally going to get an exception that gets thrown, and the reason for that is that the service, well, I think in this case I actually imported the certificate before the demo. But normally you're going to get an error, and the error is not actually very helpful. The error is just going to say the SOAP security negotiation failed. So if you see this message, that doesn't mean that you don't have the right certificate. That just means the certificate, there's probably something wrong with it. And we can take a look. Let me just run a Wireshark on that interface so we can actually see what the data that's going across the wire looks like. So if I go in and invoke one of these methods here, do 1 - 1. What we should see here is that when I decode this stream, it's actually all, the message payload is actually encrypted. What's actually happening behind the scenes here. There's one to initially negotiate the key exchange. There's about a series of 4 or 6 requests for just one service call. So this is a good example of where you're going to need to use one of these tools that support, and again, you're going to be very limited. It's going to basically be either WCF Storm or the Visual Studio Test Client. Probably a handful of other ones out there. If anybody knows of any good ones, certainly let me know, because I'm always looking for more tools that will allow you to fuzz the inputs pretty easily. So the other thing you may be able to do too is if this is a client application, if you're getting certificate errors, let's say you don't have the ability to import a certificate, sometimes that can be a little tricky. If you have a configuration file on the client, you can just turn certificate validation off. So if this is an application that you're testing, a thick client, and you're having issues with it, just go to the configuration, add a specific behavior to the config file, and that'll actually disable the certificate checks. And then the other option you have is with WCF, it also supports the classic WS Security username and password credentials. So if you don't have a certificate and it's not using anonymous message authentication, you're kind of out of luck. You're not going to brute force the certificate. But if it's using a username and password authentication, then you can easily brute force this. And this is one that most of the tools out there do support. So SOAP UI, for example, supports this. You just go to the WS Security username option, and it's basically just a plain text username and password that gets sent in a header. So you can easily try and guess this or brute force it. The one thing to point out here is that you cannot actually do this over HTTP. WCF will not allow a web service to use this authentication mechanism unless it's going over a secured transport. So again, that's kind of a good thing that Microsoft's done to sort of prevent anybody from inadvertently exposing one of these usernames and passwords in the clear of the wire. And then the last option you can do is if your tools aren't working or if they're using some ridiculous binding, because the bindings, again, there's 10 of them by default, 10 or so by default that you can use, but then there's a custom option that lets you mix and match any of those security settings. So every now and then you may run into a scenario where the tools don't actually support the binding that you're using. And if that's the case, it's very easy to write a custom test client using WCF. It's somewhere usually on average of about 10 lines of custom code. And the reason for that is you're going to leverage, as long as you've got metadata, you can leverage the service utility that comes with Visual Studio to generate an interface file, and then it's really very simple to convert that interface file into a console utility. This is basically what the custom code would look like. Once you have your interface, you just basically create a new instance of the client, and then you start calling methods on that client. So as a kind of a cheat sheet here, there's really 3 basic steps that you can do to do this very quickly in a matter of 5 minutes. The first is you use the service util to generate your client proxy. And then all you do is you can open up that client proxy, and if you just paste in this class below all of the interface code, You just add, you don't necessarily have to create a new file for every class. That's certainly the way that you would do it in a real code base, but if you're just trying to hack something together, just tag this code snippet at the bottom of the CS file that the service util generates, and then just add a reference to the system namespace at the very top. So put system using at the top. And what that's going to do is it's going to compile into an exe that you can then use to start directly calling methods on the web service. And the nice thing is it's automatically going to, let's say we're using message encryption here, for example, it's going to automatically negotiate that connection for you and do all the heavy lifting in the background. So you can really just start worrying about fuzzing those methods and not worry about all the other sort of noise that WCF would normally require you to handle. So the long and short of it is that the bindings are a bit of a headache when it comes to talking with the web service, because depending on what you need to do, you're going to have to search for some non-standard tools out there, or perhaps, like I just mentioned, create your own utility. The good news is, though, that there's plenty of room for all the classic attacks. Parameter manipulation, SQL injection, all that stuff is still relevant. It's just a matter of getting the ability to fuzz the inputs is almost going to be the hardest part. And then once you've overcome that, you're going to be in good shape. And I think what we're going to see here is, especially with .NET 4, there's a lot more extensions to WCF that they're implementing. Same thing with Silverlight. With Silverlight 4, there's a much more rich interoperability with WCF that it supports as well. So this is something that we're going to be seeing more and more, and I think it's going to push to the browser a lot more as people start using Silverlight. And right now, Silverlight only supports really a handful of those, the binary bindings. It doesn't support any of the WS security bindings, but that's certainly expected to change down the road. So I think that's something that we'll start seeing more and more of. So we've got about 10 minutes left. I can certainly do any questions if anybody's got any. Yes? The timeout threshold that I defined was anything above 5 seconds. So that's in the code. You can tweak it. I was just doing testing on that box and found that on average they were timing out around 7 seconds. So in my code, I say if it takes longer than 5 seconds, that probably means it's closed. If it's less than 5 seconds, usually if it's open, it comes back in less than a second. So it's configurable, and that's sort of why on the screen I print out the actual response time for each. So what you can really do is, irrespective of whether the tool says closed or open, you can eyeball that response time and figure out whether it's working or not. The question was if I've considered doing other plugins for other proxies. The Fiddler one, again, there's 2 people that have written them for Fiddler, and they're both read-only. So it's my understanding that that's just a limitation of Fiddler. With Burp, I think the one that we've got out there now works pretty well. The only thing I would like to do, which is one of the things that I emailed Portswigger about, was get it so that it can do responses without chaining 2 together, and that's a limitation on his API that he actually said he's going to implement another method to allow transformation after intercept. So he told me he's going to do that probably in the next few weeks or so, and then he's going to email me a beta copy of it to test. So I think my plan is just to maybe improve on the Burp plugin out there, but I think as long as the Burp one works and Burp is free, then anybody can use it. Okay. Great. Well, thanks, everybody. If you have any questions, come up after.